If you receive customer monologues about it being a slog to load your site's catalog, but you can't diagnose it because of a clogged backlog, it'd be logical to set up a logging flow that, number one, doesn't slow your application down, number two, doesn't store your data in a proprietary data store, and number three, will scale gracefully as the amount of log data grows. There are a few ways to do this, and a common one is to dump all of your log events into a database like Elasticsearch, but Elasticsearch is pretty resource hungry, and it turns out there are now more specialized tools for consolidating logs from across many application nodes, making them easily and quickly searchable. A log management platform called Parseable is the sponsor of this video, so huge thanks to them for supporting the channel. It is this support that allows me to keep making videos, so thank you. Parseable is free, open source, and written in Rust, so it's ultra fast and memory safe. It actually uses the ActixWeb framework under the hood, which we've talked about a fair amount on this channel, so it serves as a great example of the powerful things that you can build with ActixWeb. It stores your logs in a columnar file format called Parquet, and you can either store them locally or in something like an S3 bucket, so you always maintain ownership of your underlying log data, and you can always use whatever tooling you'd like to query them. One option for looking at your logs is Parsable's built-in web interface, or you can use whatever specialized tools you'd like, including something like Apache Spark or a visualization tool like Grafana. When trying to keep the size of an application's logs under control to keep costs under control, a traditional solution might force you to shrink the retention window such that logs get deleted sooner. I mentioned that Parsable stores all logs in the Parquet format, so instead of relying on a really short retention window to keep costs under control, you can just leverage a cost-effective storage mechanism instead, like an S3 bucket. Okay, hold up. How does all this work? Well, Parsable has a server-side component which exposes REST APIs for the submission of log events. Your application can either submit log events directly via HTTP requests to the APIs, or it can just write logs to files on disk, and you can use a logging agent like FluentBit, Vector, or Logstash to send that log data to Parsable. We are going to dive more into what that looks like in this video. Parsable does have a concept of what's called log streams, which are a logical and physical grouping of log data. For example, if you have separate services, they would probably each have at least one log stream. Each stream has its own schema, which is actually inferred automatically from the first event submitted for that stream. I mentioned that Parsable has log ingestion APIs that can either accept a single event in a JSON payload or multiple events in a JSON array. There are some other handy APIs, like an API called getStats, which you can use to see how large each log stream is. There's also an alerts API that allows you to configure specific log data that should trigger an action like a webhook or a Slack message. Okay, let's go ahead and walk through a few of these scenarios. There is a way to get Parsable to store logs locally, but we're just going to cut to the chase and have them stored in an S3 bucket because I think that's more representative of what you might do in production. So we've created this S3 bucket here called Parsable bucket. This is going to be the source of truth for our logs. This is where Parsable is going to write logs to. And when we query Parsable, it's going to read from here. So when we have everything working, we're going to have some files in here that contain our log data. We are going to install Parsable via a Docker image. Before we do that, we need to create a configuration file. And for that S3 bucket that I mentioned, I've also created a user with full access to this bucket. So I've already done that behind the scenes. Setting all that up is kind of outside the scope of this video, but we have a user that has full access to this bucket, and we have the access key and secret key for that user that we can put in the configuration file that we're going to make for Parsable. So let's go ahead and create that configuration file. It's going to be called Parsable env. And I'm just going to copy and paste this all in here and kind of go line by line what these mean. The important things in here are the address that we're going to expose the Parsable UI at, and also expose the Parsable APIs. That's going to be essentially localhost. And then we have credentials. So in production, you wouldn't have these credentials, obviously, but when you're kind of testing this thing out, you can have some simple basic credentials. I'm going to specify the S3 URL for my bucket, the bucket name itself, and then again, the access key and the secret key for the user that has access to that bucket. So we're going to save that, and then we're going to create a directory called staging, which is where Parsable is going to store some metadata. And we're going to link the staging directory in our host file system to the running Docker container, so Parsable can write to that directory. So we'll do make dir Parsable staging. Then we'll pull the Parsable Docker image. So we can do docker pull Parsable /Parsable :latest. And you can see I already have it. And at this point, we should be able to run the Docker image. So I'm going to copy and paste this command in. So we're going to run on port 8000. We're going to map port 8000 in the running Docker container to port 8000 on our host machine. So if all goes well, we should be able to point our browser to localhost :8000, and we should get the Parsable UI. We're going to specify the environment file that I just showed you that we just created. That's going to set up some environment variables inside the Docker container. And then we're going to link the staging directory /staging inside the Docker container to Parsable /staging on our host machine so that it can write metadata. And then of course, we're going to specify the image to create the container from, which is Parsable /Parsable :latest. Instead of storing data locally, we're storing it in an S3 bucket. So we have Parsable S3 store at the end. Let's go ahead and run that. At this point, we should be able to point our browser to localhost Yep, and we get the UI. Admin, and boom, we're in our UI. It's not a whole lot to see here yet, but we're gonna change that very quickly. I did mention logs, the concept of log streams. So the first thing we'll do is create a log stream to put data in. And we're gonna assume we're making a hypothetical journaling app. So we'll call it journal app. And we can create that log stream using a simple curl request from the command line. So I'll copy and paste that in here. And this is just making a request to the REST API exposed by that running Docker container. And the URL is /v1/logstream/journal app. So in the URL, we're gonna specify the name of the log stream that we're gonna create. And we're using basic authorization for now because this is just a demo. So this base64 string here is just literally admin:admin base64 encoded. So if you wanted to use something other than admin, you could compute the base64 encoding for that and use that, but we'll do that. And then at this point, we should see, yeah, we have a journal app log stream. So pretty simple to get up and running with Parsable. There's a ton of different strategies for actually getting log data into Parsable. So we'll kind of go over the main ones one by one. Potentially the easiest method for getting off the ground is to just submit log events directly to Parsable via its REST APIs. And we have a hypothetical app written in Rust using the Leptos framework. Let's see what it takes to create a log event each time somebody actually tries to retrieve a journal entry using the app. Keep in mind, this is not the only way to get log data into Parsable. It's just one of many ways, the rest of which we're going to go over in a bit, but it might be the easiest way to get started and just kind of kick the tires on Parsable. We're going to write the code in probably a way that you wouldn't actually write in production. For the sake of the video, we're going to keep all the relevant code in one place. In reality, you'd probably put bits and pieces here and there to make it cleaner, but we're going to encapsulate the entire sending of a log event to Parsable in one function. So we have this get entry API, and what we want to do is send a log event every time somebody makes a request to this API. So we're going to wind up calling this function log to Parsable here after we write it. So async function, and it's going to take a user ID and a date as parameters, and also an action. So in our journaling app, we have a concept of users, and each user has a set of journal entries, each of which is associated with a date. So we want to know who the user was, which entry they were requesting, and what were they trying to do with it? Were they trying to retrieve it, or were they trying to update it or create it or whatever? So that's what action is. For simplicity's sake, we're going to make all these string slices for now. We're going to start with the parsable URL of the log stream that we want to write to. Again, you'd probably have this configured via an environment variable in a real world scenario, but we're just going to hard code it here for simplicity's sake. We're going to be making HTTP requests. So there is one crate we're going to have to add to our project, and that's request with a W in there. So we're going to do cargo add request, and then we need the JSON feature. So we'll do -F and then JSON. Cool. And then we can just make a hash map with the fields that we want to record in our log entry, and we can just assign them arbitrary values. So we have essentially the hash map that we want. Now we just need to create a request client. We'll create a use statement for the request client here. And then I'm just going to paste in the rest. It's a little bit verbose. We're making a post to our Parsable URL, which is localhost 8000, and then the log stream is journal app that we're posting to. We have our authorization header, which again is similar to what we did when we created the log stream. It's just the base64 encoded admin:admin string. And then of course we're sending JSON, and then we do .json and then pass in the hash map. That's automatically serialized into the body of the post request. And we send it and await the result because this is an async function, and then unwrap. So we're ignoring errors here. Also, don't do that in production. And we're going to go ahead and call this function at the beginning of get entry, passing in the user ID, date, and we're just going to hard code get here. We do need to add a .await to this call to log to Parsable because it's an asynchronous function. Now this should have compiled automatically, and it did. Let's go to our rudimentary UI. This is not an actual journaling app, by the way. This is kind of a toy user interface, but we'll make a request to the get entry API for user Bob and do 2023 March 1st as the entry date, get entry, and let's see if we get that log in the Parsable UI. And there we have it. We got our log entry. So we get a timestamp that's populated automatically, and we see all the fields that we added to that hash map in the code. And if we look at our bucket, let's refresh this here. There's a structure of directories. Well, S3 doesn't have directories, but it has prefixes. So we can kind of navigate through them as if they're directories. So we have like essentially a directory for hour, a date or day, hour, and minute. And then we can see our Parquet file is right here. And that's the columnar file format that Parsable stores logs in. So we can see our logs in the Parsable UI. We can also do full-blown SQL queries using the query API. So let's take a look at that using Postman. I'm not going to go too deep on Postman here, but you can see we have our path. It's just /API/v1/query. It's a post, and we have this JSON object in the body with some fields, start time and end time, and a query. And this query supports full-blown SQL basically. Log streams sort of act as tables in a SQL context here. So we do select star from journal app, and we're going to get everything from the journal app stream. And different columns in the log stream act as columns in kind of a SQL context. So I can do select star from journal app, and I can see the one log event that I have. I can also do something like select count star from journal app, and I get a count. You can do things like select user ID, so one column from the log stream, and we get the user ID from our one log event. You get the idea. You can do some pretty powerful things here. Another useful API is the stats API, and that allows you to get various statistics on a given log stream. The path for the stats API is /v1/log stream, and then the name of the log stream, and then /stats, and it's a get. And by the way, these all require the same authorization headers that we showed when we were creating the log stream. So we have an authorization header with the base 64 encoded version of our credentials. So when I do a get for the stats of log stream, I can see various things like its size on disk, the number of records, the storage format, so on and so forth. There's also a retention API, which allows you to specify the retention period for your logs. It accepts some JSON configuration. So if you did want to delete your logs after they're 20 days old, you just use a duration field of 20 days, action delete, and then you can associate a description with it if you want to remember what this was for. And this is a put. So now our logs will automatically be deleted by Parsable once they're 20 days old. The other really nice thing is that you can use a visualization tool like Grafana, because there's a Parsable plugin for Grafana that will attach to your Parsable instance and populate charts based on data it got from Parsable. Let's take a look at that. So we're in Grafana now, and if we go to plugins and search for Parsable, we can see that there's a Parsable plugin. You can install it here. I already have it installed. Pretty simple, and that allows you to use Parsable as what's called a data source if you're not familiar with Grafana. So then if I go to data sources, I can specify where my Parsable instance is in the data source. And then once this data source is set up, obviously I just have it set to localhost 8000 with the basic credentials that we've been talking about, admin. And once I have the data source set up, now we can go ahead and create a dashboard with a panel that includes this chart that reads from this Grafana data source. So go to dashboards, new dashboard, add a new panel, and we can see our Parsable data source appears here. We can select a log stream, and you actually get the column names, which is kind of nice for that log stream. So you can kind of reference that while you're writing the query. We're going to make a really simple query. We're just going to do select p timestamp and 1 as value from journal app. I'm going to expand the time range really quick. I added some data points since that initial data point that we created. So you can see we have 2 data points here. This query is obviously very rudimentary, but you can go crazy with this. You can do some pretty powerful things here with visualization. There are actually quite a few log agents that work with Parsable, but the one that we're going to use is called Vector, and it's actually pretty popular. You can see here it has 13,000 stars. And again, the goal here is to have an application that writes logs to disk and then have Vector automatically kind of scoop up those logs as entries are created and send them off to Parsable. So our hypothetical application will have a directory dedicated to its log files. And there might be multiple log files in there, each with a different name, and it'll create new log files on the fly and potentially delete old ones as they become outdated. And Vector kind of has to keep track of all this and keep track of which log entries it's actually submitted to Parsable and which it hasn't. So yeah, it's pretty cool what log agents will actually do automatically for you. Let's see what setting up Vector looks like. We can pull the Vector Docker image, kind of like we did for Parsable. And then we're actually going to create a vector configuration file. I'm going to copy and paste that in. We'll call it vector.toml. And there's actually a lot of stuff going on here. The main things you need to know about Vector are that there's a concept of sources and a concept of sinks. And sources are where it's getting its log events from. That could be something as simple as the console. So it might take input from standard input and consider those as log events. And then it has a concept of syncs. So I have some log data coming in from my sources. Where do I want to send that log data? And that's what a sync is. It's somewhere that we're going to send our log data. In this case, our only sync is Parsable and our only source is app_log. And app_log handles the situation that I just described where we have an application that's writing some log files to a directory. Each log file might have an arbitrary name and they're kind of ephemeral. They'll be created on the fly and they might be deleted on the fly as well. So Vector needs to keep track of the state of each of those log files and which entries it's submitted to the syncs and which it hasn't. And to do that, it needs a data directory. So we're specifying a data directory /var/lib/vector. We're going to map that to a directory on our host system so that because this is running in a Docker image, it's able to write metadata to that data directory. That's kind of the gist of it. So in the Parsable sync, we're going to configure our things like our credentials, the URI to the Parsable instance. Because Parsable is also running in a Docker container, it's actually forwarding its port 8000 to 8000 on the host machine. So for Vector to connect to 8000 on the host machine, we need to do this host.docker.internal:8000. Using that URI, it should be able to connect to the Parsable instance. And of course, we have the path to the log stream. Another important field in the vector toml file is this method field, and we want to set that to post explicitly. Otherwise, you might get a 405 error when Vector is trying to communicate with Parsable. So watch out for that. I'm going to post this entire configuration file in my GitHub repository. So if you want to look at it and copy and paste it and modify it for your needs, yeah, the link for that will be down below in the description. Before we get started, we do need to create the log stream that we're going to write to, or that we're going to have Vector write to. So this is kind of similar to what we did before, but instead of calling it journal app, we're going to call it something else. We're going to call it demo2. So now we created the log stream and we can run our Docker container. We're mapping various parts of the file system on our host machine to the file system in the Docker container. For example, we're mapping the vector.toml configuration that we just created to a place in the Docker container. We're mapping an app log directory, which is where we're going to create kind of our artificial app logs, to a directory on the Docker container. That data directory where Vector stores metadata about what log events it's submitted and which it hasn't, kind of storing its internal state. We're going to map a directory on our host system to a directory in the container so it can write to that to keep track of that metadata. We'll go ahead and run that. Now we should be able to write arbitrary log messages to log files in the app logs directory. So let's go ahead and cd into that. And we can do something like echo hello world and pipe that to some arbitrary .log file, say test.log. And now we should see this show up in the demo2 log stream in the Parsable UI. And we can do something like echo welcome. Okay, so now we can see our log messages in the Parsable UI, and you get a file name and the message and the timestamp and everything you might expect. That's how to set up Vector to collect messages from your application's log files and submit them to Parsable. So with this setup, the nice thing about setting up Vector is that you don't really have to make any changes to your application code. If it's already writing log files to disk, there's absolutely no code changes necessary in your app to accommodate Parsable log setup. So that's really nice. Now let's talk about Kubernetes. And Kubernetes is, for some people, the only way to deploy software these days. Vector and Parsable both have first-class support for Kubernetes, so you can install both of them using the Kubernetes package manager, which is called Helm. Let's look at how to install Parsable and Vector on your Kubernetes cluster such that your Kubernetes logs get pushed up to that S3 bucket and thus are visible in the Parsable UI. We're not going to use a full-blown Kubernetes cluster here. We're going to use what's called Minikube, which is a way of setting up a local kind of mini Kubernetes cluster on your local machine. We're not going to go into too much detail on Kubernetes or Minikube. It's kind of out of the scope of this video, but you'll be able to follow along even if you're not familiar with them. First, we're going to create a configuration file, pretty similar to the one that we made before, but this one is catered specifically to using with a Kubernetes cluster. So we'll do nvim Parsable, we'll call it Parsable env secret. And you can see it has a lot of the same stuff. It's got our S3 credentials, our credentials for the part that we want our Parsable instance to have, path to the staging and data directories, so on and so forth. We're going to start Minikube first. Okay, Minikube's running. We're going to use kubectl to create a namespace for Parsable. Create ns Parsable. And then we're going to create a secret file. Kubernetes has a special way of handling things like credentials. So for that, we're going to do kubectl create secret generic Parsable, and then we're going to pass it our file that had our credentials for Parsable and our AWS credentials. We're going to point it to that file, and we're going to put it in the Parsable namespace. Now, Helm is kind of like the package manager for Kubernetes, and we want to grab Parsable and Vector. So we'll do Helm repo add Parsable. And you can see I already have it. And then we'll install Parsable on our namespace. namespace Parsable. Nice. And then we'll set up port forwarding so that we expose the port exposed by Parsable on our local machine so we can navigate our web browser and see the Parsable UI. Again, in namespace Parsable. Cool, so at this point, we should be able to see the Parsable UI in our browser. This was the one that running on our local machine. Remember, we stopped that, so let's just refresh. We have the same streams in here, and that's actually because when we installed Parsable in Kubernetes, we're still pointing to the same S3 bucket, and the logs for these log streams still exist in that S3 bucket. So we're gonna see the same data in this UI, even though this Parsable instance is running in the Kubernetes cluster instead of on our host machine. So that's Parsable. Now let's try installing Vector on the Kubernetes cluster. Parsable does provide a kind of default vector configuration file for using on Kubernetes. So we're going to grab that really quickly. And then similar to what we did for Parsable, we're going to install Vector using Helm. And you can see I already have it. And then we'll install it onto the cluster. Cool, that should do it. Now let's look at the UI and see if we can see our cluster logs coming in. So with Kubernetes, your application can scale elastically. You can add or remove nodes on demand. And installing Parsable and Vector on your cluster, you can add and remove nodes without worrying about your logging. Regardless of how many nodes are there, they're all going to send their logs to one place. And so your logs are consolidated in whatever storage mechanism you want, be it S3 or something else. And they're all surfaced via the Parsable UI and also via the query APIs that Parsable supports. In this video, we showed two main ways to ingest log events, via direct HTTP requests and via a log agent like Vector. Another way is via direct integration with AWS Lambda using Lambda extensions. If you're using Kafka, log events can also be ingested via a simple subscription to a Kafka topic. If you're not familiar with it, there's a popular open source monitoring tool called Prometheus. Another notable feature of Parsable is that you can monitor it through Prometheus. You can also send real-time alerts based on log events in the form of Slack messages, PagerDuty pages, or email. Parsable also does have some interesting things on its roadmap. For example, there's plans to provide gRPC support for log ingestion. There are plans for role-based access control, so you'll be able to assign roles to users that grant them access to specific log streams. There are plans to support multi-tenancy via Kubernetes operators, integration with OpenTelemetry, and also for clustering multiple Parsable instances. So yeah, if you want to get a better handle on your logs so you can identify customer pain points and root cause issues faster, check out Parsable, especially if your application is running on Kubernetes, but even if it's not. Again, it's completely free and open source. Many thanks to Parsable for supporting the channel. You'll also want to check out this video about a Redis compatible data store called Upstash, especially if you're building systems at scale and you're considering different cloud database options. Thanks for watching, and we'll see you in the next one.